To study one blue planet takes another whole blue planet, planet Earth. Many people look to the future for international space missions, but global cooperation, in fact, is here today, as you can see in the operation of the far-flung network of radio antennas used to receive the radio messages from the distant Voyager spacecraft. The signal from Neptune is so very weak that when it gets back to Earth, it's 20 billion times fainter than the power level needed to operate a modern-day electronic digital watch. To collect this feeble signal, which carries all the information that has given us the astonishing images we have seen, NASA uses antennas around the world. Since the Earth is constantly turning, NASA regularly uses 3 main ground stations in California, near Madrid, Spain, and at Tidbinbilla in Australia to ensure the spacecraft is never out of touch with Earth. It was Tidbinbilla that was the main receiving station for Voyager at the time of her closest encounter with Neptune. There was intense excitement as Voyager approached first Neptune, then Triton.
I think it was right about that time, within a second or two.
The 27 antennas of the Very Large Array in Socorro, New Mexico played an important role. But the experimenters who use changes in the radio signal as Voyager flies behind planets and moons to determine what kind of atmosphere is out there also wanted extra receiving capacity. The answer was a new and very valuable link in the global network. CNN correspondent Taylor Henry has a special report from Japan.
It was an historic moment in international space exploration. Japanese and American scientists teamed up at the Yasuda Space Center about 125 miles northwest of Tokyo, using its giant antenna to receive and monitor one of a pair of radio signals coming from Voyager 2.
Communication is going very well, so we are using very close communication.
Scientists maintain communications by way of open phone lines between all 3 monitoring stations and NASA's command post at the Jet Propulsion Laboratory in Pasadena, California. Yasuda received Voyager's S-band signal, while the other signal, the X-band, was picked up in Australia. Scientists watched closely as the spacecraft sailed over Neptune's North Pole, disappeared behind the planet, causing a visual blackout, and much to the relief of everyone present, emerged as expected on the other side, sending back more signals. The data was recorded onto magnetic tape and timed by an atomic clock. Scientists will examine the recorded changes in the strength and frequency of the radio signals, changes caused by their being bent or refracted through Neptune's atmosphere. The findings, expected to begin coming in a matter of days, will reveal much about the planet's atmosphere, including what it's made of, its temperature, and location of clouds.
Facilities like Yasuda opened less than 5 years ago. The leaders of Japan's young and rapidly growing space program hope to become major world players in space. Their role in Voyager's encounter with Neptune now serving as a big milestone. Taylor Henry, CNN at the Yasuda Space Center, Japan.
The radio science experiments went flawlessly, and experimenters at JPL say the Japanese data will prove essential to understanding Voyager's discoveries. Like their Japanese colleagues, they hope it's just another milestone in ever greater global cooperation. The end result of all this process is more and more data flowing back into JPL, revealing Neptune's true colors. Carl Sagan and Sidney Poitier got together to discuss some of the intriguing questions that sometimes get lost in the high technology and jargon of big science.